Learning Target 9 says I can find an equation for a polynomial that goes through several points using Lagrange Interpolation. So the idea behind this is you'll be given a table and you need to find a polynomial that fits that table. So the very first thing you're going to do in Lagrange Interpolation is you're going to rewrite your table as the sum of a few simpler tables. So here's what I mean by that. We're going to say that our original table is equal to the sum of three other tables. So for the first one, I'm going to call it a of x. The second one I'm going to call b of x. And the third one I'm going to call c of x. And what I'm going to do is within each of these tables, I'm going to keep one of the f of x values the same and change the other two to be 0. And so we'll see why that's helpful in just a second. So our x's are staying the same. And within each of these tables, again, we're going to keep one of the f of x values to be the same, and we're going to make the other two be zeros. So for the first table, let's keep the output that goes along with -1 the same, that's 3, and let's make the other two be zeros. For the second table, let's keep the second b of x value the same, and the other two will be zeros. And for the last one, let's keep the third c of x value the same and make the other two be zeros. So if you notice, if you add up these three tables, we're going to get the original table. But the thing that's nice about this is that each of these individual tables have a bunch of zeros in them. And that's going to make it easier to write a polynomial that fits each of these individual tables. So basically our method here is we're going to take our original table, break it up into the sum of a few simpler tables. We're going to come up with a polynomial that fits each of these individual tables, and then we'll add them up at the end. So let's get started working on that. So let's focus on trying to find a polynomial for a of x. So if we know that 2 is an intercept, an x-intercept for a of x, then we know that x minus 2 needs to be a factor. So we can start out by saying a of x needs to equal. We know x minus 2 will be a factor. If 3 is an x-intercept of a of x, then x minus 3 needs to be a factor. Now there's also going to be some leading coefficient in front here. We don't know what it is yet. We're going to have to actually solve for it. But for now, let's just put in a little placeholder. I like to put a capital A to stand for my leading coefficient for now. So what we're going to do is we're going to use the last point that's left over in that table to solve for your leading coefficient A. So the idea is that this is an equation that's supposed to fit your table for any x and A of x value in the table. So in particular, this equation should be true when you plug in -1 for x and when you plug in 3 for a of x. So let's actually go through and do that. So when x is -1, a of x is supposed to be equal to 3. So all I'm doing here is I'm taking -1 and plugging that in for x, taking 3 and plugging that in for a of x. So the next thing that I'm going to do is I'm going to solve for my leading coefficient a. So let's simplify the right-hand side as much as we can. -1 minus 2 is -3. -1 minus 3 is -4. So we get 3 equals a times 12. Now this is a place where a lot of people make mistakes. To solve for a here, to get a by itself, we need to divide both sides by 12. And so we get a is equal to 1/4. So we know that the polynomial that fits the very first table is going to be 1/4 times x minus 2 times x minus 3. So now what we've done is we've found a polynomial that fits our very first table up here. So next, we need to find a polynomial that fits our second table, our b of x table. So Let's do that off to the side here. So let's see. So we can see that -1 is an x-intercept of b of x. So that means that x plus 1 has to be a factor. We also see that 3 is an x-intercept of b of x, which means that x minus 3 needs to be a factor. And then there might be some sort of a leading coefficient out in front here. We don't know what it is yet. So then we're going to use our last point that's in the table that we haven't used yet to solve for the leading coefficient, capital B. So we see that when x is equal to 2, we're supposed to get out -18. So what I'm going to do is plug in the 2 for x and the -18 for the output b of x. I'm going to solve for my capital B. So again, after I do that, I need to simplify the right-hand side as much as I can. 2 plus 1 is 3, and 2 minus 3 is -1. So I get -18 equals b times -3. Once again, to solve for our leading coefficient b, we're going to divide both sides by -3. And we end up getting b is equal to 6. So our final polynomial that fits our middle table is going to be 6 times x plus 1 times x minus 3. So at this point we now have a polynomial that fits our first table and our second table, but we still have this third table over here that we need to find a polynomial for. So let's see. I'm going to have to scroll back up and down, sorry. So let's see, so in C of x, we can see that -1 and +2 are the x-intercepts. So that means that x plus 1 and x minus 2 are going to be the factors. So down here, let's start writing our polynomial C of x. We get some leading coefficient c times, we said x plus 1 and x minus 2. And what we want to do now is we want to use our last point in the table to solve for our leading coefficient c. So let's remind ourselves what the last point in the table was. So it's the point 3, 8. So when we plug in 3 for x, we know we're supposed to get out 8. So we have 8 equals c times 3 plus 1 times 3 minus 2. So again, simplify the right-hand side. So we get 3 plus 1 is 4, 3 minus 2 is 1. So we get 8 equals c times 4. Again, let's divide both sides by 4 to get c by itself, and we get that c is equal to 2. So our polynomial for c of x will be c of x equals 2 times x plus 1 times x minus 2. So what we've done is we've found a polynomial that fits each individual little table, and our very last step is going to be to add those polynomials all up. So our final answer is going to be pretty long. So I'm going to put it in pink. So f of x is equal to 1/4 times x minus 2 times x minus 3 plus, imagine this was all in the same line, I'm just sort of out of room, plus 6 times x plus 1 times x minus 3 plus 2 times x plus 1 times x minus 2. And again, imagine this was all just written on the same line right next to each other. I'm just out of room. So this is our final answer. And unless I have a really good reason to make you simplify this, I won't make you simplify, multiply out, and put it in standard form. So you can just leave your final answer like this. So let's just remember what the steps for Lagrange interpolation are. So the first thing that we did was we took our original table, we split it into the sum of three simpler tables. Basically what I mean by simpler is keeping one point the same and having the other outputs be 0. Next we found polynomials that fit each of those individual tables. And then at the very end we added those three polynomials up together to get our final answer.